Your agent is a generalist. It handles everything, but it's not optimized for anything. What if your support users got an agent that's fast and friendly, your power users got one with full tool access, and your internal team got one that knows your entire code base? That's not one agent, that's a whole team. I'm Adhiraj, and today I'm going to show you how to build that. You'll set up one gateway with multiple agents behind it, each with its own personality, its own tools, its own workspace, with a routing system that sends every conversation to the right agent automatically. This is multi-agent orchestration. Let's set it up. On day 14, you went deep on agentic coding. The align before build prompting pattern, build logs for multi-session continuity, and sub-agent patterns for parallelizing development. Your agent became a legitimate coding partner. That was one agent delegating to copies of itself. Today is different. Today is about running genuinely different agents, different personalities, different tools, different workspaces, and routing traffic between them. There's 3 goals for today. First, understand the multi-agent architecture, how each agent gets its own isolated workspace, agent directory, session store, and why those boundaries matter. Second, master routing precedence and channel bindings so you can deterministically control which agent handles which conversation. Third, configure agent-to-agent communication and enforce per-agent security isolation so your agents can collaborate without compromising each other. The core concept is simple. There's one gateway with many agents. Each agent in OpenClaw is 3 isolated components. First, the agent directory holds auth profiles, model registry, and agent-specific state. Under that same path, sessions is going to store the conversation history. Second, the workspace is where the agent's soul, memory, and agent's markdown files, tools, and skills all live. It's complete isolation from the other agents. You manage the agents through the command line interface. OpenClaw agents add creates a new agent. OpenClaw agents list shows what you've got. OpenClaw agents delete removes one. It's a clean lifecycle management. And the critical rule that the docs do hammer home is never reuse the agent directory across agents. Each agent must have its own directory. Sharing causes auth collisions and session corruption, and the bugs are silent and extremely difficult to trace. Once you have multiple agents, you need to decide which agent handles which conversation. This is routing, and it's completely deterministic. The precedence order goes peer first, which is an exact user match by kind and ID, then parent peer, then guild ID plus roles, which is a server and role combination, then guild ID alone for server-wide matching, then team ID, then account ID, then channel ID, and then finally the default agent as fallback. First match wins, and if multiple bindings match at the same tier, config order breaks the tie. Whichever binding appears first in OpenClaw.json takes priority. Bindings are defined in OpenClaw.json, and the match fields include channel, account ID, peer with kind and ID, guild ID, and roles. When you specify multiple match fields on a single binding, they use AND logic, so all the fields must match. This is exactly how you create precise routing rules, like Discord users with the admin role in this specific server get routed to the admin bot. Each agent gets configured under agents.list in OpenClaw.json. Key properties here are ID for the unique identifier, name for the display, workspace pointing to the agent's workspace directory, agent directory pointing to the state directory, model for which LLM to use, default as a boolean for the fallback agent, identity for a brief description, and sandbox for the execution environment. Beyond the basics, you configure tools with allow and deny lists, skills with allow lists, group chat.mention patterns for trigger words in group context, and then memory search for configuring which search backend your agent's going to use. For shared config, use agents.defaults. This is going to set a baseline that all models inherit. The model, sandbox, mode, common tool policies. Individual agents override any property that they need to defer on. This keeps your config dry. So you want to set the common stuff once in the defaults and only specify what's unique per agent. And I'll say it again because this is the most common mistake people make. Never reuse the agent directory across agents. Every agent needs its own. Let's get platform specific now. For Discord, there's one bot per agent. You'll need to create a separate bot application for each agent, and message content intent must be enabled. Bind by peer for DM routing to specific users, by guild ID for server-wide routing, or by roles for Discord role-based routing. So admins talk to one agent, and regular members talk to another. Telegram is also one bot per agent, created through BotFather. Each agent token maps to exactly one agent. Bind by peer for DMs, by guild ID for group-wide routing. For WhatsApp, you log in with OpenClaw channels, login -- channel, WhatsApp -- account with your ID in brackets, For multi-account setups, like say you're running agents for multiple phone numbers, define each under channels.whatsapp.accounts with a separate auth directory per account. This is what keeps those auth sessions isolated. The binding patterns work across all channels. Peer bindings have the highest precedence and always win. Server or guild bindings are next, and channel-wide bindings catch everything else. Design your routing from the most specific to the most general. By default, agents can't talk to each other. This is a deliberate security choice, and you have to opt in explicitly. To enable it, configure tools.agent to agent on the agent that needs to initiate the conversation. Set enable to true and provide an allow list of agent IDs that this agent is permitted to contact. If an agent isn't on the allow list, then communication is blocked. For cross-agent memory, you use agents.list.memorysearch.qmd.extract This lets one agent search another agent's memory store without sharing session context. It's read-only, so agent A can search agent B's memory, but it can't write to it. Session isolation is maintained through the key format, which is agent::agent ID::main key. Each agent keeps its own conversation history, even when two agents handle the same user. There's no bleed through between agents. The design principle here is that the communication is explicit and auditable. You can see exactly which agents talk to which, exactly what memory was shared, and exactly where the boundaries are. There's no implicit sharing, and there's no hidden state transfer. Security in a multi-agent system comes down to per agent controls. Each agent gets its own sandbox mode, off, non-main, or all, and each agent gets its own tool allow or deny lists. Each agent gets its own skill allow lists, and critically, each agent gets its own auth profiles.json. DM sessions collapse to main per agent, meaning each agent sees only its own session history for a given user. Cross-agent sessions are keyed separately, so even when two agents handle the same person, their conversation histories never bleed into each other. For maximum isolation, the pattern is one agent per person, so each user gets a dedicated agent with its own workspace, memory, session store, and all. This is the absolute gold standard when data separation is legally or contractually required. Two things to watch for here. First, never share your agent directory. I've said it 3 times now, and that's because it's the single most common multi-agent misconfiguration. Second, relative paths stay inside the workspace, but absolute paths breach the sandbox. If an agent can write to an absolute path outside its workspace, your sandbox isolation is useless. Audit your tool configs to make sure nothing allows the absolute path access. 4 tasks before day 16. First, add a second agent. So run OpenClaw agents add and create a new agent with its own ID, workspace, and agent directory. Verify it shows up in the OpenClaw agents list and triple check that the agent directory is unique. Second, bind it to a different channel. Configure a binding in OpenClaw.json so your new agent handles a specific channel, server, or user. Test that messages actually route to the correct agent based on your binding rules. Third, configure different tools and skills per agent. Give each agent a different tool allow deny list and different skill allow lists. One agent might have a full exec access while the other is read only. Verify the restrictions hold by trying to use a denied tool. Fourth, test routing end to end, send messages from different channels, users, or roles, and confirm the routing precedence matches what you configured. Also check that your default agent catches unmatched traffic as expected. Here is where you stand after 15 days. You've built personality, memory, tools, skills, heartbeats, subagents, and now multi-agent orchestration. Your system isn't just one capable agent, it's a coordinated team of specialized agents, each with its own workspace, its own security boundary, and its own role. Day 16 is the finale, which is workspace files. Every file, every config, every interaction, we're going to cover it. It's one definitive guide to running your OpenClaw system in production. It ties everything from the past 15 days into a single reference you'll come back to over and over again. If you want help setting up multi-agent architecture for your team or business, consult with me at aliradtranquil.com. And if you want to be around other people building and selling AI automations, join the free AI automation sprint. The link is in the bio. Subscribe so you don't miss the finale, and I'll see you on day 16.